Okay, good morning. This is Professor David J. De Los Rios. It's September 12, 2023. The time is 2:46 a.m. Okay. My subject matter for this session will be a long video format discussion, and this will be on college algebra. And we are running smooth on college algebra. For those who are following my channel with the discussion college algebra, we are running smooth. We are now on lesson number 59. Okay, let's proceed. The topic for this morning will be college algebra, and this will now be lesson number 9, a continuation of our long video format discussion on college algebra. The title of the subject matter will be Binomial Theorem Extra. Extra meaning it will be a different variation of problems under binomial theorem. Okay, let's proceed. Example number 1, under extra. This is a different variation of problems. Okay. Evaluate the expressions. Okay, we are given two expressions. Anyway, the solution is just short, so I will give you two expressions for example number 1. Evaluate expressions 6 factorial all over 4 factorial times 2 factorial. The next expression is actually subscript 6, capital letter C, subscript 2. Forward subscript, this is the back end subscript. This actually represents the so-called binomial coefficient. This is termed to as binomial coefficient. Just be aware of this one because this might come out or may come out on the SAT exam. They might ask you to evaluate 6 capital letter C with the subscript 2. So at least we now know what is that notation. This notation is actually the so-called notation for a binomial coefficient. Meaning, if we try to expand the binomial expansion, okay, there will be coefficients in every term. And the designation for the coefficients in every term is actually designated like this. That is 6C2. Actually, the equivalent of this, I will try to give you. Where is it? This one. 6C2 is actually the equivalent of open quantity, closed quantity, n r, and this should be equal to n factorial over r factorial times the quantity n minus r factorial. This is the equivalent of the given expression 6C2. Okay, let's try to proceed let's try to evaluate the first one. This is an easy one. Pero at least we now know how to evaluate a factorial notation. Okay, so this will be an extra problem under binomial theorem. That is what you call the simplification of an expression involving factorial notation. 6 factorial all over 4 factorial times 2 factorial. 6 factorial is actually 6 times 5 times 4 up to 1. Or we can stop at 4, then we will place factorial. Because 4 factorial is actually 4 times 3 times 2 times 1, right? But we can write it as simply 4 factorial because we are thinking of some cancellations later on. So, the numerator can be written as 6 times 5 times 4 factorial all over. The bottom portion, there is a 4 factorial on the bottom portion. Okay? So this is 4 factorial. And the 2 factorial is actually the product 2 times 1. Then later on, try to make some cancellation. 4 factorial, cancel with this. We can cancel because the operation on the numerator and denominator are all multiplications. So actually we can make cancellations. Right? So 4 factorial, cancel with this. What comes out will be 6 times 5. This is all over 2. The answer will be 15. Okay? That's expression number 1. That's the final answer for expression number 1. Expression number 2, okay, don't be afraid with this. You are afraid of this if you do not know what will be the meaning of 62. 62, I am telling you, it's the so-called binomial coefficient. Right? And there is a formula or there is an equivalent for a 62. If we try to rewrite it, it will be open quantity, closed quantity, NR. Okay? And if we try to simplify this will be n factorial over r factorial times quantity n minus r factorial. Where the value of n is actually the first one. The value of n is 6. The value of r is actually 2. So if we try to simplify, if r is 2, n minus r will be 4, right? So substituting now, this will be 6 factorial, we're following this, all over r factorial, which is 2. N minus r is actually 4 factorial. Okay? Then try to make some cancellations again. We will rewrite 6 factorial as the product of 6 times 5. We stop at 4 factor 4. Then we'll just simplify it as simply 4 factorial instead of writing 3 times 2 times 1. Okay? It doesn't matter if you want it to be expanded, no problem. All over, the bottom portion will be 2 factorial, 2 times 1. The next one will be 4 factorial, right? So this is 4 factorial. So just the same as in the first solution, this 4 factorial cancel with this. We can cancel because the operation on both the numerator and denominator are all multiplications, right? So 6 times 5 over 2, the answer will still be 10. Okay? These two here are extra problems under binomial theorem. A different variation of problems under variation of binomial theorem. Okay, next example. Oh, I forgot to place a red mark here. Okay. Evaluate the given expression 5 factorial. Am I still on camera? I think so. Hold on. Evaluate the given expression 5 factorial all over 5 factorial times 0 factorial, and this should be equal to. The catch of the problem here is the value of 0 factorial. Okay, if we try to simplify this one, 5 factorial over 5 factorial times 0 factorial, then rewriting the given expression 5 factorial with the open quantity, closed quantity, right? Then the bottom portion, this is open quantity, closed quantity, 5 factorial. And what is the value of 0 factorial? From now on, okay, even though you're sleeping or maybe you're daydreaming, 0 factorial is actually equal to 1, okay? Don't forget this one. So, this 5 factorial cancels, right? So, this will be 1 over 1 times 1. The answer is actually 1. Okay. It has not been proven in our textbook that 0 factorial is 1. They just say that 0 factorial is 1. But if we try to check this one, we just display 0 here on our scientific calculator. Factorial is in the second function, right? Second function, factorial. The answer is 1. Okay? So by using the calculator, 0 factorial is 1. So our textbook is saying that 0 factorial is 1. So it is really 1. Okay? Oh, that's the equivalent of 0 factorial. It is 1. Okay? So our answer here is 1. Okay, last example for this morning. Find the middle term of the given binomial expression x squared plus 2y raised to the 6th power. Okay? The value of n is actually 6, right? And from the annotation of binomial theorem, if we expand a binomial expression, the total number of terms will be n plus 1. So I place it here, n plus 1 will be the total number of terms. So n plus 1 now will be 6 plus 1. So this will be 7. So meaning to say, if we expand this binomial expression, there will be 7 terms. So if there will be 7 terms, there is a middle term, right? And if we try to imagine, the middle term will be the fourth term. So we solved the problem already. We are solving for the middle term. And if we try to imagine there are 7 terms, the middle term should be the fourth term. Therefore, the r term now, if we try to bring out the equation on how to take the r term will be n factorial over r minus 1 factorial times the quantity n minus r minus 1 close bracket factorial times a raised to n minus r minus 1 b raised to r minus 1. This is just the formula, okay? The designation a and b is just a designation in our discussion of concepts, right? So it could take any value. And here, for the given expression, that a is actually x squared, and the second term is actually 2y, and that's the second term. And n is equal to 6, r is equal to 4, because we are looking for the fourth term. So if we try to compute r minus 1 and n minus r minus 1 separately, r minus 1 will be 4 minus 1, r minus 1 will be 3, right? We just do it separately, so we will be systematic. N minus r, the quantity r minus 1 will be 6 minus 3. So n minus r minus 1 is actually 3. So going back to this formula here, okay, the middle term is actually the fourth term, so we'll place it now. The fourth term should be equal to, we'll follow this. N is actually 6, so this will be 6 factorial. R minus 1 is 3, so this should be 3 factorial. N minus r minus 1 is also 3, so again, the multiplier here is 3 factorial times the expansion of the two middle terms. The expansion of the first and second terms. Okay. The highest power of x starting on the first term is actually 6, right? 5, 4, 3, right? So this is the first term, this is the second term, third term, this is the fourth term. So meaning to say, for the fourth term, the exponent of the first term will be 3. So this is x squared raised to the third power, right? The second term is 2y. No problem with this. Since the total number of the total value of n is actually 6, 6 minus 3 will be 3. So the exponent of the second term will be 3. Because a 3 plus 3 is actually 6. It should tally with the given n. And simplifying this one, 6 times 5 times 4 times, we stop at 3 factorial. There is 3 factorial at the bottom. Then we try to expand the second one. Because I am thinking of cancelling this 3 factorial here, cancel with this. Okay, and this 2 and 3, 6, cancel with this. Right? So what remains on the exponent will be this one. The first on the exponent, it is 20, right? X squared raised to the third power, it will be x raised to, take the product, 6. Right? And if we try to expand 2y to the third power, 2 to the third power is 8. Y to the third power is y cubed. So the overall coefficient will be 8. Am I still on camera? Okay. 8 times 20, and that will be 160. The first term will be x to the 6th power now, and the second term will be y cubed. So the final answer will be 160 x to the 6 y cubed. Final answer. Okay, as simple as that one. So these are the extra problems under binomial theorem. And I think the next time around we will be discussing a new topic because we are almost done with college algebra. If I could find any subject matter, what you call this topic which is needed in the study of college algebra, I will try to add it up on the next time around. Okay, good morning from Los Angeles, Professor David G. De Los Reyes.